All right, let's have a look at this now. Uh, find these roots and write down a cubic equation Z for which Z1 and Z2 is one of the roots. Okay, let's get the roots here. That will be Z cubed plus 2 cubed equals 0. That will be Z cubed minus, let's think about this for a second. I cubed is I squared, which is minus I. So, oh, sorry. What am I doing? We don't need to mess around with imaginary numbers yet because we have a formula for the sum of cubes. I was thinking of this sum of squares. Right, so the sum of cubes formula. Let's see if I remember that one off the top of my head. That's Z plus 2 for sure. And then Z squared minus Z plus 2 equals 0. So that means Z equals minus 2. Or Z is 1 plus or minus the square root of B squared, which is 1 minus 4AC, 1 minus 8 minus 7 over 2. So 7I, I think, with a root, sorry. 1 minus 8, yeah. Okay, so yeah, we just want the complex roots. So Z1 equals 1 plus I root 7 over 2, and Z2 equals 1 minus I root 7 over 2. Let's double check that. Yep. Now, the product. So Z1 times Z2, so that's going to be all over 4. And on the top, we get 1. Then the middle 2 will cancel, and you're left with minus I squared 7, which is plus 7, which is 8 over 4, which is 2. Write down these roots and write down a cubic equation in Z for which Z1, Z2 is one of the roots. Okay, so we just want the root to be 2. So I guess it would just be the cubic Z cubed minus 8 equals 0. Okay. Evaluate that, power 12. All right. Polar form time. So that's going to be positive a quarter. Okay, so that's going to be here. So the or, which is the modulus of Z, which is a quarter squared plus root 3 over 4 squared, which is 3 over 16, which is 4 over 16, which is 1 over 4. Oh yeah, with the root. So that's a half. And then tan theta equals minus root 3 over 4 over 1 over 4. So it's just tan inverse. What have I done to my calculator? Tan inverse minus root 3, which is minus 60, which is good. So this, we'll call this for the moment Z power 12. So Z power 12 would equal or power 12 cos theta plus I sine theta power 12, but De Morgan says you can bring the 12 down here. So the or is a half. Ooh, Oh, is that right? It'd be much better if the r was 1. 1 over 4 squared plus root 3 over 4 squared. Yeah, it's a quarter. So that's going to be 2 power 12. That 1 over 4096. Okay. And then 12 times minus 60 is minus 720. Cos of minus 720 is 1. And then sine of minus 720 is 0. Okay, so it's 1 over 4096. Perhaps they were expecting students to leave it as 1 over 2 power 12. All right. On the Argand diagram, plot the set K. So again, I'd write it as Z minus 0 plus I is equal to 2. So located at I is a circle of radius 2. So let's see, that's I, 1 plus I, 2 plus I. Might have to put my, okay, let's see now. Located at I, a radius of 2. And then that's minus I. So it has to come down there. Okay, and then it will go over to minus 2. So it'll go over to there. And it'll go up to 3. Okay, so that's 2 plus I there. That's 3I. That one there is minus 2 plus I. And then that one there, 3, 2, 1, 0, yeah, minus I. So there's four points on the circumference here. It's just the boundary, because it's equal to 2, not less than or equal to 2. Okay. Right, let W equal 3Z plus 2. If W equals U plus IV, express U and V in terms of X and Y. Okay, so if W equals 3Z minus 2, that means W plus 2 over 3 is equal to Z. So that's U plus IV plus 2 over 3. So that's U plus 2 over 3 plus V over 3 I. And Z, remember, is X plus IY. So that means X is equal to U plus 2 over 3. And then Y is equal to V over 3. And then plot the image. So the way I like to do it, and I won't have space to draw it on another diagram, but if you look at what's happening here, you can see the Z, first it gets multiplied by 3, and then it gets translated to the left by 2. So for example, if I put this in like red, this was here. If it gets multiplied by 3, it's still here, and minus 2, it's now here. So the center is now translated to the left. 2 plus I, if we multiply that by 3, we get 6 plus 6i, so it's right up here. 6 plus 6i. And then if you translate to the left, that will be 4 plus 6i. And that's probably enough, because to make a circle, we just need the center and the a point on it. So that's up there now. So maybe I should do some more. This will become, this one here will become Oh, I said multiplying by 3 doesn't affect that, didn't I? But that's wrong. So for example, I would become 3i minus 2. So that's there now. And then let's take the 2 plus I. So the 2 plus I, that would become 6 plus 3i minus 2, which is equal to 4 plus 3i. So that's been moved there. Minus I would become minus 3i minus 2. So I'm definitely going to run out of space. So, yeah, I'm not going to fit in. So that's the new center there, and there's 2 points on the circumference then. Yeah. Okay. Oh, I've misread that question. Because usually, it's funny, because when I was doing the other questions, they usually have the other way around. Don't they usually say express x and y in terms of u and v? Let me have a look. Yeah, now that's funny. That's really funny, because I think the first time I was doing a question like this was the 1993 paper, and it said express x and y in terms of u and v. And at the time when I was recording that video, I remember saying that seems a little bit strange, because I think it would be easier to do it the other way around. So in this year, it is the other way around. So out of habit, I did it the way they asked in previous years, or I guess later years. But no, interestingly, this one is the other way around. Express x and y in terms of u and v, and that's actually better. That's actually better, I think, anyways. So here, w is u plus iv, and z is x plus iy minus 2. So you get u plus iv equals 3x plus 3yi minus 2. So you have u equals 3x minus 2, and v is equal to 3y. And that's better, because you can see kind of more clearly what's happening with your points kind of quicker. So like, for example, if you have your points, let's say x plus iy, and then here is u plus vi. I think the first one I did was I, 0 plus I. So then the u would be 3 times 0 minus 2, that's minus 2, and the v would be 3i. And that's exactly what I said. If you take, say, the point on the top, which I haven't done yet, that's 0 plus 3i. So the u is 3 times 0 minus 2, so that's minus 2, and the v is 3y, so that's 9i there. So that point there moved way up to 9i, which is off my graph then. Yeah, so this I much prefer. You can't see the questions because I have them open here on the website, but if you look at 1993, they don't say express uv in terms of xy. They say express xy in terms of uv. If you look at 92, they don't say either way. If you look at 91, they say express xy. If you look at 1990, they don't say. 89, they don't say. 88, they don't say. And now 87, this one here, express uv in terms of xy. I wonder, maybe I'm missing something here. I wonder why that switched. I much prefer it this way because it's very easy to map the points. Don't know. Maybe someone can enlighten me.